Entity framework.
Hot chocolate.
Azure Cosmos DB. Entity framework. Power tools.
Technology suite.
Countdown commencing. T-minus 2 minutes.
Jeremy Lickness.
Shay Rojansky.
Grace Lanson.
Arthur Vickers.
.NET data. T-minus 1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Stand-Up.
Yeah, we're back with another .NET Data Community Stand-Up, keeping it sargeable as always. It's too bad you guys can't see behind the scenes while the intro's playing because we're all like dancing away to the theme tune there. So yeah, right. Let's go. So today we are doing another kind of deep dive into EF internals. We did one previously where we looked at the internal service provider and how EF uses DI to manage its internal services. And today we're going to kind of continue that with looking at the life cycle of a DbContext, looking at how it's initialized. There's multiple steps to that. There's like creating the instance, and then there's actually initializing the services and building the model and such. So we're not going to go into details of building a model, but we're going to do the other stuff. And then we're also going to look at how that changes when you use DbContext pooling, and so how you get some better perf by using pooling instead of doing some of that stuff multiple times. So that's the plan. I'm going to basically step through the code and pretend that I understand it, and we'll see how that goes. There's already been places as I've been looking at it today where I'm like, yeah, we should change that, So anyway, we'll see how it goes.
Live refactoring.
We're not going to change it live. That's something we could consider in the future, but not right now. No.
The test pass, we're going to production.
Yeah, exactly. Before we get started, let's just look at what's going on in the state of the unicorn. In daily builds, we have materialization interception. Materialization, one of those words that we throw around. It basically means creating and initializing entities. Like when you query a product from the database, we create the product instance, we set its properties and stuff like that. So this is something that we had an object materialized event in EF6. A lot of people have been asking for that. This is now in EF7, although it allows you to do more than object materialize. You can actually intercept before or after the object creation. So you can say, oh, actually don't create it. I'm going to create it for you and use that one. So for example, to create a proxy or something like that. And then you can intercept before and after we set property values. So you can do some other stuff rather than the normal property values. And all that gets compiled into the expression trees for our query shapers. So basically, you essentially get a compiled delegate calling your stuff in line with our query materialization. And if you don't use it, we don't change anything. So no hit on perf for people not using materialize interception, which is very important. Shay's nodding there. Also, so I've been working on lifecycle hooks, as you can see. So another one we have here is an interceptor for identity resolution. So what that means is that when you do add, attach, update, and you're attaching a graph of entities, if we find an entity with the same key, an already tracked instance with the same key as the one that you're adding, the default behavior there is to throw, because we can only track one instance with any key value. What this does is it gives you essentially a callback that lets you say, okay, instead of throwing, I actually want you to copy over, for example, the values from the new instance and set them into the one that's being tracked, or possibly just ignore the new instance. I know I'm tracking some and I don't care about that. I just want you to ignore them and keep going. So in general, identity resolution for graphs is a difficult problem. If you've got different sets of relationships between them, resolving what to do in those cases is tricky. So, but this gives you a way to handle at least easy cases, which a lot of scenarios are. Just a parent with a list of children, for example. So it can handle that. So those things are in the daily builds now. We've also got certain PRs out there. Shay's put out a PR to the .NET Runtime repo for distributed transaction support. This is Windows only. It's got native code in there. The runtime architects may kick that out and say we're not allowed to do that, but we'll see how that goes. So yeah, so hopefully we'll get that in for .NET 7, but we'll see how it goes. There's some more change tracking events. So we have tracking and state changing. So you can actually, before we only notified you after we'd already changed the state. People want to know before we change the state, so this helps with that. And then if you want to know when detect changes is kicking in, it will tell you that as well. So there's some events there. Entity splitting is still an ongoing thing. There's PRs out for that from Andri, and Marisi is still working on JSON columns. So hopefully those will get in first. So that's basic state of the unicorn. So let me now, unless we have anything before, otherwise I'll get straight into sharing my screen for the actual code that we want to look at today. So there it is. Share that one and add it to the stream. Okay. So what I have here, I've got the EF Core code base open, and in order for us to be able to easily kind of step into the code and see what's happening in certain situations, I've written an XUnit unit test here. Think of this as just a console application, but because the solution is set up for unit tests, it's easier to do it this way. And what we're going to do is we're just going to new up a context. So I have my DbContext down here. It's very simple. It's got an on configuring saying use SQL Server. We're doing some. Ooh, did I do that? Okay.
Did you do
that's cool. Anyway, we're doing enable retry on failure. So this is just an example of execution strategy for SQL Server. This is just an example of a SQL Server option. And then we've got DB sets for blogs and posts. They're not even realistic blogs and posts. They're just anything. So basically, this is just to let us see what's happening. In the test, we're going to new one of these up, and then we're going to get the model from it. So there's two stages to DbContext lifetime initially. One of the stages is actually creating the DbContext instance, which doesn't involve actually initializing any services. So it doesn't involve, for example, getting the model or anything like that. And so that's faster than if you actually start using it. We do lazy initialization. So our way of using it in this case is just asking for the model. So this is going to create the instance and this is going to initialize it. The reason we have those two steps is that it used to be, and it probably still is in some cases, quite common to, for example, inject a DB context into a controller, but that controller might only in 10% or 5% of cases actually do anything with the context. For example, it might only save changes if something has been added to a form, or it might only do a query if it needs to. And so if we were initializing the whole DB context on construction, then that would make the whole controller slower in cases where it didn't need to. That's perhaps less important now we have pooling, but nevertheless, it's still there and it still can be useful for places where you are not using pooling. I'm going to debug into this test and we'll see what happens. Okay, so it's running the test and it should hit the breakpoint any moment now. Yes, when you do live streaming, things tend to slow down, but it will get there. I'm confident.
Can I have the cat?
Come on, unit test runner. You can do it.
Okay.
Let's all move our
Yay.
mouses clockwise.
Yes, exactly.
Okay.
We've done it. Right. So let's jump into creating the DB context. In the DB context constructor, I don't have any constructors defined explicitly in my DB context. So it's basically calling the parameterless constructor, the default constructor. And when you do that, internal, so this is EF core code now, internal there, what we see is that we basically just create a new DbContextOptions and call into the other constructor. This is the constructor that typically gets called when you're using DI and you've done add DbContext, which has created a DbContextOptions in the service provider. And if you remember back to last time we talked about DI, this will then get in, the DbContext will get injected into it. So it kind of unifies together. We'll show a little bit later that you can just call this constructor directly as well. So let me run it. So go to there. Okay. So just to check that you're using a right DbContext options object. Now there's a bunch of stuff here that we're not going to go into in detail. The gist of this is that we want to now initialize DB Set Properties. So if you remember, if we go back to the test here and look at my context, I've got these DB Set Properties here with getters and setters, and we're going to set these to a value, right? This is a thing that EF code does for you. Shay.
Yeah, this is actually this has some impact on nullable reference types. It's a conversation we've always had. So in fact, this code, if you look at it, it's problematic, right? Because you have DbSet from a nullability perspective. You've got these DB sets. They're not nullable. There's no question mark there, but nobody's initializing them, right? So in fact, if you try to compile this with nullability enabled, this will generate warnings, right? Because you have not initialized those things. However, as Arthur just showed, the base constructor here will actually use reflection here behind the scenes and will go and inject these properties with the DB set. So in fact, they are kind of initialized on construction, except that the compiler doesn't know it. And I'll use this just as a shameless plug. In EF Core 7, another thing that we've actually done, is to silence those nullability warnings. So the compiler cannot see that EF Core is going to be doing this initialization, but we can actually include something called a suppressor, a diagnostic suppressor. Like you have analyzers and source generators, there's a lesser known thing called a suppressor, which will see those nullability warnings and will say, oh, no, these are happening on DB set properties of a DB context. So we actually know it's fine because EF Core takes care of that in the base constructor. And so we silence them, we suppress them, and everything is fine. But it's kind of weird when you look at it. It's when you're very used to EF Core, of course, it looks very natural. But from from a pure C# perspective, it's a little bit weird. You have these properties; they're magically kind of
It is. It's very weird. Yes. Okay, so yeah, so we're getting a service provider to do that. We're not going to I think this is a piece of code where, you know, I thought, yeah, we should change this now. We should do this a little bit simpler without some of this stuff. But the important thing here is we get this service called an IDbSet initializer, and we're going to call initialize sets on it. So I'm going to step into that. Okay, so initialize sets is a service that has itself depends on two services. So, you know, refer back to previous, you know, the service-oriented architecture we have here. So it has a set finder and a set source service that it depends on. And the set finder, basically, the point of that is to go through and, like Shay said, use reflection to find the sets, set properties, DB set properties on the DB context. Now, that's actually used in two things. We need it for initializing DB set properties, but we also need it to find query routes. So it's actually has two uses, which is why it's kind of separated out into a service. So let's go and step into the find sets and just see how that works. Okay, so
Arthur, just really quickly, for those who don't know, can you explain what a query route is that it's finding?
a query route just means the thing that is iQueryable on the DB context. So when you have a DB set of product or of blogs, to keep it consistent, then that is an iQueryable blog that you can then compose link queries on. So you can say where the product, the blog name is one unicorn or whatever it is. So the query route is the root of that query, essentially. And DB sets properties, the DB sets act as both query routes and as objects for accessing, doing adding and removing of things that are tracked and various things like that. Okay, so so we actually have a cache here. So this is a service that keeps a cache of the sets on a particular DB context. And this is so that we don't run the reflection code multiple times, because looking things up by reflection is relatively slow. But since this is the first time through it, we're not going to find anything in the cache. And so it should just jump into this method here. And so if I F5 there, you can see we have jumped into it. Now we're creating a property setter factory. This is for creating the delegates that will actually set the properties, but we'll come back to that in a minute. And then here, what we're doing is we're saying, give me all the properties on the context type that you've passed in. I don't want anything that's static. I don't want anything that's an indexer. I want things that are generic. I want things that are generic type definition is DbSet. We're going to order them, and then we're going to create these things called DB Set Properties. These are basically tuples, but this was from before we had pretty nice tuple support. And so rather than having to use item 1, item 2, item 3 like you had in the old days, we actually just have our own read-only struct record for this thing. But conceptually, it's just a little holder for these things. And
we can clean it up.
We could clean it up, yes. It's a name, it's the type of the DB set property, and then it's this thing which is an interface that basically holds a delegate for setting a CLR value. So you pass in the instance a set and you pass in the value and it will do that. Okay, so go back here. So if we jump into this and let's go and look how we create that delegate, because that's quite interesting. So I'm going to say go to there. Okay, so we're in again. This is a place where we have a cache involved, and so because we don't want to create those delegates multiple times, the whole point of creating a compiled delegate is you can create it once and then you call it multiple times to make it fast. This code is actually used both for setting properties on entities and in this case for setting properties on DbContext. The code is written from the perspective of setting properties on entities. So some of the names in the code don't really make sense here. For example, we call the type of the thing that you're setting on T entity and we give it a name entity, even though the type in this case is a DbContext. perhaps we should be more general here, but this is kind of reuse without actually changing that stuff. And most of the time it doesn't really matter. So I'm not going to go into all of this. Basically, we're setting up. This is building expression trees. If you don't know, so let me say a little bit about that without getting too bogged down in it. So I'm sure most people are aware that when you compile a language, it compiles into basically a syntax tree, a collection of nodes that form the expressions of your language that you've compiled into. In C#, you have these methods on generally on the expression class that allow you to build an expression tree manually, rather than the compiler creating it for you. So instead of writing some code and compiling it into an expression tree, which is then further compiled into the actual intermediate language that gets run by the virtual machine, in this case, you're building the expression manually. So you're saying here, well, I want two parameters here, and then going through here, we see whether we need to convert the parameter into something else. So that's kind of like adding a cast if you were writing the code, but in this case we add a convert node to the expression tree. And like I said, this does a bunch of stuff that's for entities that have special cases, but for DB set properties it's pretty simple. We basically create this member assignment, and I'm just going to let it, well, it's down here, you can see what it is. It's saying create an assignment expression. Well, so there's two cases, index a property or not index a property. And then if it's a non-indexer property, we're basically saying made a member access. So in this case, we're saying, okay, at member access is, in this case, assigning to a property. And so we're saying make member access and assign this parameter. So that probably isn't very easy to understand, but if we look at the actual right expression that we got out of here, this is what it looks like in a kind of debug view. It's saying entity, remember that's our context, set the blocks property to the value of the parameter. So it's basically just a context.blogs equals blah. And we are then going to come down here and say, okay, make that into a lambda, so make a function out of it. It's not technically a function in this case because it doesn't have a return value, right? You're not returning anything from it. You're passing two things and saying, passing the context and the value and saying set the value onto this thing in the context. So it's an action rather than a function, but conceptually it's the same thing. This right expression is what we had above. This says what the body of the function, the delegate that we're going to compile is. This is the entity parameter that we're passing in. So in this case, the DbContext. This is the value that we're passing in. So whatever, when we've created the DB set, whatever that is. And then we create this expression and we compile it. And what you get out of that is a delegate, an action, a type, my DbContext and DbSet. So these are the two parameters that you pass in, like we said. So you pass in a context and a DB set, and then it will assign that DB set to that property that we've compiled into the expression. So we've compiled an expression here. And I know it's kind of hard to get your head around some of that stuff, but it's also pretty awesome.
Yeah.
Okay, Shay, you want to say something?
Yeah, just so what we're doing here is cogeneration, right? I hope everybody
Yes.
is aware of this. So I used to, like 20 years ago, I wrote some cogeneration in another universe, in another galaxy far, far away. And you used to do this. There were many ways of doing this, but you would write a program. Like I used to do this in Perl. So I wrote a Perl script that would generate C++ code. And then you got the output of that was an actual file containing C++, which you then compiled. So that would be a form of compile time code generation. You generate C++ code, and then you compile it, and you've got a program that's been tailor compiled to some configuration or whatever it is that you needed to do. And the reason you do this kind of thing in general is that you don't, when you actually run stuff, you don't want to go through, you don't want to do those things every single time. You want to basically generate a piece of code that's going to be tailored to exactly what we want to do, and then compile it so that it doesn't contain any extra ifs or loops or checks or whatever, nothing of that sort. You just want to generate exactly what you want. In this case, what we're generating is a piece of code that's going to populate a DB set property on a context. I hope everybody could follow that. The actual details with expression trees are super cool, but that's the general kind of thing. And the one thing I'll add, just for context, so the amazing thing that we're doing here, unlike my Perl thing with C++ from 20 years ago, is we're doing this cogeneration at runtime. So when your program comes up and starts working, this is when we're actually generating code at runtime for those things. And we can do that because C# has a JIT, and we can compile. We even have like the compiler and the JIT, and everything is happening at runtime, as opposed to doing everything at compile time at some point with actual compilation of C++ or C or whatever. So that's a thing you can do in C# and certain languages like that, which you cannot do in a language, or not easily anyway, in a language like C and C++. So it is pretty cool. Yeah.
Yes. So just a little digression from what we're supposed to be talking about, but that was a fairly simple example. I was talking about materialization interceptors. So this is a case where, or actually basically this up here, this comment says, this is the code I'm going to generate. It's something like this. This is really pseudocode. And then you can see we create various expression variables. We say we're going to assign this to new, we're going to call that, we're going to convert that. It is, as was mentioned in the chat, it is difficult to debug, it's difficult to write, it's difficult to understand. But for cases like materialization of a query, it's an order of magnitude faster than using reflection every time and setting the values. And so it's the only way, really, if you want a fully dynamic ORM experience, to get this. Now, you could say, okay, we could pre-do some of this beforehand, and we have ideas for that, but it would never be as flexible as just allowing any link query to be analyzed, compiled into, and run as a delegate.
So I had two things really quick. I think Shay touched on this, the whole point of, if you're going to use reflection repeatedly, this is a way to compile that step of reflection and have it high performance. The other thing, we can defer this if it's too much of a discussion for what you're going to cover, but this comes up quite a bit, right? Why DbSet as opposed to interface of DbSet?
Yeah, I think that would probably result in us going too far off what we want to do here. That's not really relevant to how we initialize things. It's more about how we expect the context to be used, whether we expect it to be mocked in certain ways, the historical problem that if you changed an interface, you added a member to an interface, then it would be a breaking change for anything that implemented it. So we chose to go to a abstract base class, which is what DbSet actually is, rather than an interface, so that we could add new things to DbSet without breaking any existing implementations of that. Now, whether we really needed to do that, it's questionable, because should anybody else be actually implementing a DbSet? I don't know. Had we gone with IDbSet like we did in EF6, it was a nightmare, because we wanted to add new things to DbSet, but we couldn't add new things to IDbSet without breaking it, and so the two things diverged, and there were things on DbSet that weren't on IDbSet. Now, interfaces now have default member implementations, or whatever those are called, that make this slightly less good. But I think maybe also we wouldn't recommend that people create their own mock DB sets very often either. So it's a complex area, some history, some philosophy, some practicality. It really shouldn't make any difference. If you really do want to mock your DB sets, you can mock your DB sets. It's an abstract base class. In fact, we'll see that in a little bit. We'll see how that actually works. I wouldn't recommend doing that, but you still can do it.
Nice.
Was anything else, or should we move on?
Maybe one last comment is that this whole runtime cogeneration is very cool, but lately there's a whole shift in EF Core to thinking about AOT as well. So there is, when you run on various form factors, when you want to run on iOS with Maui, when you want to run on Blazor client on WASM, there are certain scenarios where it's desirable to do ahead of time compilation. So to have the whole program basically compiled into native at, just compiled ahead of time rather than having a JIT. And in those situations, having a JIT and doing runtime cogeneration is actually problematic. EF Core makes uses this very liberally. There's a lot of runtime cogeneration going on for very good reasons, but it is one of the things that make it a challenge to make EF Core compatible with AOT. We do have a lot of thoughts about this. We may work on this in a future release, but it is one of the problems.
Yeah, indeed. Okay, so let's come out of this and assume we've now created our delegate. Okay, so we've created the DB set property. Let's keep going through this. Okay, so we're going to do it again now because we remember that we did it before for the blogs property, and we're now going to do it for posts here. See, we're doing it for posts now. Okay, so we'll just jump over all that. Okay, so we found our sets. We've got our sets. We only want ones in this case where the set doesn't have a setter. Remember, we actually want to be able to find DB sets even if they don't have setters, because you can still use them as query routes. But we can only set ones that have setters, kind of obviously, right? So for each one of those, we know that the setter, this is the thing the delegate thing we just created. We can call into that with this set CLR. This is all we have here is an interface that wraps around the delegate in this case. And we pass into it, for each of these, we pass into it the context. And then we actually, rather than newing up a DB set instance explicitly here, what we do is we also have a dictionary of the DB sets on each context instance, right? And that's what this get or add here is doing. So I think if I don't know if I step into this is where we could lose ourselves, but we'll see. Oh no,
Down
we're
the
good.
rabbit
We're
hole.
good. Right. So why are we doing this? This is because whenever you have whenever you use the DB set for product, we want to give you the same instance, which seems, you could say, well, okay, that's good because now I'm not newing up new instances to be garbage collected, but that would be that advantage is not a very strong reason to do this, especially if you're doing a dictionary lookup every time to get the instance, right? Then you're kind of saying, well, I've got perf for that. What is important is some of the things that actually hang off DB sets. For example, the .local property that lets you get access to the local entities, they rely on those things being able to track information about what's happening in that DB set. And so it's actually really about making sure we have a consistent use of that. So in these DB sets, we're back on the context now, and we're going to create this if it doesn't exist, which it doesn't yet. So we create that, and then we'll try and get a value out of it for the current type that we're looking for. So we want a DB set for blog. If it's not in there, then we actually use the DB set source to create an instance. And I think this is basically going to not do anything very much particular other than make sure that we return here an internal DB set. So remember I said DB set was actually an abstract base type. It is. And internal DB set is the thing that has the normal implementation of that we use for EF Core, which is not particularly useful, but at the time we did this, there was a lot of arguments and we wanted it to do this. And part of the reason for this is so that if you mock these things, then we basically throw not supported exceptions for things you don't have in your mock, rather than doing things that don't make sense that require proper initialization and all that. I don't think any of that is very much use, but the important thing here is that basically all we're doing at the end of the day is creating an instance of a DB set. Okay, so here we go. We've created it, and then we add that to cache. in the set source. So that means that we've got a source of delegates for creating DbSet instances, so that each time we create a new context instance and we want to initialize the DB sets, we don't have to re-figure out how to do that. We've just, again, generated the code to do that. Although there isn't actually any code generation there, it's really just selection of a type to create. And then we put it into the dictionary. We tell the context, if you've been doing some caching, you need to, this is a separate kind of level of caching, you need to reset that at that point. And then we return the set, which then gets passed to set the CLR value. And so now we've set that property on the context. And we'll do that again, and then I'll stop for questions in a minute. So we do this again for posts.
Arthur, we've had one request to zoom a little bit, if that's possible, to help people out.
There you go.
Okay.
So we've done that. Let's return there. So we've initialized all the sets now. Okay, so we've got back to this place that we had basically in the DbContext constructor, and our context now has those sets initialized. We do a little bit of event source stuff there, and we pop out of our context, and now we have a DbContext that is, we have the context instance and we have values for the DbSet properties, right? Okay, it's not, as I talked about earlier, it's not initialized to do anything yet. We don't have a model built, we don't have those things, right? Okay, Shay.
Yeah, so there was a discussion in the comments whether this whole thing, like going over, the properties, generating the DB sets, is that not going to be inefficient? And should I not be, doing it myself, bypassing it myself? Is it good? So first of all, you can absolutely not use this mechanism. You can define.
I'm actually going to show that.
Oh, okay. Yes. Sorry.
But
in that case,
no,
maybe
so you can talk about it now. No, that's fine.
Okay, no problem. So you can very easily just say, okay, I have a DB set property, but instead of just doing get and set like you saw up to now, you just make it not settable. You just do get, and then it's your responsibility to initialize it. And EFCore has a function called set, which you can use to retrieve a DB set. So you can just initialize it using that, using that function call, basically. But the real answer here, which is really the most important thing, is if you're really concerned about speed at this level, and the differences in speed are ever so small here, it's really not supposed to make any difference. But if you are concerned about any of this, you can always turn on context spooling, and none of this matters at that point at all, because you're going to be doing this once for the constant context instance, and then it just goes to the pool every time, and we recycle it again and again. Yeah. So we don't have to re-inject, recreate, and re-inject those DB set properties. So I would say to anybody worried about perf here, if you really are worried about perf, just do DB context spooling, and then you don't even have to think about any of this. It's all just going to happen once at initialization.
Yes. But remember that we're caching a lot of this work. So a lot of this work that you're seeing here is not happening every time, which is why in the test here we're doing it twice. So we're going to show that.
Even if you are not doing DB context spooling, this is pretty fast still and should not impact anybody at all.
Yes. Okay, so let's now, we'll come back to that in a minute, but let's now actually initialize the context to do something. And the way we're going to do that is just ask for the model on it. And if we look in the model, the thing that we do for pretty much all of these things is we ask for the context services. And these are basically going back to last session with the internal DA, these are the services that the context itself uses in order to make things happen. And this property, this is basically where the context services will be initialized. Let me run into here. So we're asking the model, the first thing we've done is say, give me the context services. Now it may be that when you're running in the debugger will evaluate things. And sometimes that causes stuff to be initialized that wouldn't normally be initialized if you don't run in the debugger, right? This is an issue with lazy initialization. So I think what we're going to find here is that these services are actually already initialized. So what I'm going to do is I'm going to stop the whole thing here and start again. And we're going to get to this point without having the debugger evaluate some of that stuff, hopefully, if it all works right. So Just waiting for it to go again. Wow, it's amazing how time flies when we're doing this stuff. Okay, so we've done all that, we've done 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 that. Hey, context services. So we'll see now context services wasn't initialized like we would expect to be the case. We have a reentrancy check here. If you're already initializing it, you can't use it while you're initializing it, right? This does not have to be thread safe. We're not checking for race conditions here. DbContext is not thread safe. If you've got two threads trying to initialize a DbContext at the same time, then you're in a blow up situation, which we try and help you detect in other ways. But my point here is there isn't anything here that says try and stop two threads coming in and initializing at the same time. This is a reentrancy check. This is don't re-enter the initialization code while you're initializing. So pretty simple. Okay, so now we create a DbContext options builder for the options that were passed into the context. In this case, these options are empty because remember back in the constructor, we called the empty constructor. Had we already built some options with add DbContext or by passing some explicitly into constructor, this would be there. This would already have some configuration. But in this case, we're just going to build an options builder around it. And then we're calling the onConfiguring method. So this is where now onConfiguring will add additional configuration to any existing configuration that you had. We jump into that, we're just back in our code now. It's just called onConfiguring our code, and we're doing these use SQL Server and all of this stuff that we know and love, right? So I'm gonna skip over that. So we've now got in our options. Actually, maybe I should have stepped into that. Might have been useful, but let's see. Yeah. I'll maybe no. I'm going to stop and actually go into that because that's actually an important part of this. So I'm going to run again here. So bear with me while it starts up again. And we're going to see what happens when you call use SQL Server or one of these other options, which is essentially while we're waiting for that, what we're going to do is when you do a use SQL Server method, actually let's get there. Maybe I'll not do some of these. No, I'm going to leave that. Leave that because I want to show that again later. Go through here. Okay, so we're in here again. Okay, so we go through this stuff, go into onConfiguring, and then let's jump into use SQL Server there. Okay, so what's use SQL Server? So it's an extension method, right? And it's written in a different assembly, completely separate. And so we have to use this to add additional options to what Entity Framework normally uses. And the way that is done is these things that you may have had encounters with, which are options extensions. So every extension, every provider has its own options extension. And in fact, EF has a thing called core options extensions, which it uses the same mechanism for just all of the core options. And what we do is we basically say, okay, create me one of these, a SQL Server options extension. So let me jump in and just show that. So it's going to say, okay, is there already one there? If there is one, that's great. I'll have it. I'll use it. If not, I'm just going to create a new one of these. So fairly straightforward. And then we should have stepped into with connection string, but we can look at it anyway. And then when you use with connection string, what it's going to do is so options extensions are immutable. And there's a few reasons for that, but the most obvious reason here is if you, for example, have done DbContextOptions in your add DbContext and you have a DbContextOptions that's now being resolved from your service provider and is used for every instance that is returned. And then you have onConfiguring that is configuring only the instance that you're currently using, then you don't want to mutate the DbContextOptions for everyone. So instead, what we do is I was thinking I was stepping over that code, which I wasn't, but that's fine. We create a clone of it, and then we set the new option. In this case, we're just setting the connection string, and then we return the clone. Okay, so what we've got here is the extension with the connection string set, and we can see here, indeed, the connection string has been set. Okay, there's some code for configuring warnings because that has a kind of interesting API, but we don't need to go into that. And now this other thing we have on here, this is the SQL Server options action. So if we go back to our on configuring here, you see we passed this sub builder, this nested builder pattern. And this is where SQL Server is able to do its own things, right? It's able to do its SQL Server specific configuration. So in this case, we're setting an execution strategy there. And so this is basically what we're doing here is we're invoking that. So let's see, let's do that. And you see here, indeed, we're now back into our code that we configured in the DbContext, and we're having it do enable retry and failure, which essentially creates a new execution strategy, and again does a same kind of immutable thing there, where it says create me a new one with that factory, and when we get back out of all of that stuff, we've now got configured into it our SQL Server specific options. And so we'll return the options builder from that. So that now has basically, we've now done use SQL Server. If we continue to jump in, for example, to log2 here, again, it has a similar thing where it's, again, basically doing the same kind of changing the options. And let's go to here. It's doing with option and setting that. So again, that's creating a new option. So each time it does these things, we're getting updated options. And once we've done all that, we fall out of on configuring, at which point we have the full DbContext options created. So now our context has all of the configuration that it needs. We do some checking there that you're not changing it when you shouldn't be, which goes back to kind of to the pooling scenario that we're going to hopefully look at later if we get time. And then we're going to go into the service provider cache and get an instance of the service provider. So this then ties into what we looked at last time, where we build different service providers, and the options for the SQL Server tells it which services to use, and we end up with a service provider that we can use for the currently configured options. So refer back to last time for this. The point of here is that once we get it, we create a scope for it. And this is the scope that gets used for this DbContext instance. Remember, each DbContext gets scope services, which are used for that context instance, shared by that context instance, and then go away at the end, and singleton services that are shared by all DbContext instances. Okay, so we've got that. We're going to get from the scope service provider that we've created, we're going to get an instance of this DbContext services, which, if you remember, this is basically what we're creating here. This is the thing that manages those services that the context uses to do its work. And there's kind of a create it and then initialize it because of a chicken egg thing with DI here. But if we go into initialization here, we can see we're basically doing some checks that you've only got one provider installed. So we say, give me all of the iDatabase providers that you've got there. If there's more than one, say that's wrong. If there's none, say that's wrong. Otherwise, return it back. And we've got initialized context services, which we store in the context so that when we come back into this next time, we will just return it and we won't do this all again. So this is kind of this is the lazy initialization. And then we do some logging. Interestingly, when we do logging, it actually calls into context services. But since context services has already been set, we're good. We just return it. So we don't actually get the recursive entry thing there because we've already initialized it. Okay, so that's basically initialization. And now, remember what we were doing. If we go back to our test here, what we were asking for here was the model. When you ask for the model, it goes to the model property here. Go to the implementation of that. If you've got a model already cached, it returns it. Otherwise, it calls this create model, and that's where we are now, right? So now we're saying, okay, create the model. And we're not going to go out. We'll do another session. If I can figure out how model building works, we'll do another session on how model building works. Again, we have a don't recursively build the model thing. And we get a bunch of options. We're doing some model building. And then essentially here, we're calling, let me just step into that. We have this thing called model source. And by default, the model source has another cache in it. Okay. And if we don't have a model for this DB context in the cache, you can change the cache key, which is one thing you might do for multi-tenancy, for example. But if we don't have one in the cache, then we go into this code here. Now, in this case, we are actually in a place where we're multi-threaded because the model is shared by multiple context instances. So multiple contexts instances could be saying, give me model at the same time. We have to make sure that's safe. So we have a sync object for that. And then we basically say, okay, if the cache still doesn't have one, we double check locking there. Don't get me into it. And then we're doing some set finding for model building as well, because it needs to know in order to get DbSet names and things like that. So end result of all that is, it's asking for the database, context services again. I've skipped through to this. So we've got the model basically and returned it there. I skipped through quite a lot, but in the interest of time, I'm not going to go back. You see what's happening basically. We went in it and we asked for the model, and now we're disposing the context, which, since we're not using pooling here, this is fairly trivial stuff. Okay, so now we've got to a point where we've done all of this once. We've created a context instance once, and we've initialized it once. And so we're going to do that again, just because I want to just demonstrate how a bunch of that code only happens the first time because of the caching that we did. So let's again go into here. So we're in our DbContext constructor again. And in this case, when we jump into initialize sets, so let me jump into that. And we go and jump into the set finder. See here, remember we've got this breakpoint on the thing that actually does the reflection to find the sets and create the delegate for the property setter and everything. Well, if everything is working correctly, this is not going to be called this time, right? It's just going to get it out of the cache. And indeed it did, right? It just returned right away. So all of that stuff doesn't happen the second time. It only happens the first time. And the only thing that happens the second time is that we go through and set each value. And because we've got a compiled delegate to set each value, we're not even doing reflection or anything on that to even find the property to set. We just call the compiled delegate, and it will set those values, which is what makes it a lot faster than trying to do it all by reflection every time. We do have to create DbSet instances again each time, because those are different for each DbContext instance. That's not a cache thing. You have different DbSet each time. But if we pool them, if we use DbContext pooling, then there will be cache, which we'll look at in a minute. Okay, so I'm going to quickly go over that. And let's go out of there. We've set the sets. Do it again for this one. Out. Okay, so we've created the sets and set them. Now, keep in mind that we're doing all of this again, which we wouldn't do for pooling. So when we look at pooling, we'll see how pooling can help by not doing this again. Okay. Now we're out and we've created our instance. So a lot less work than we did the first time, still some work. Let's go and now get the model again. Okay, so again, we're going to see how caching is used in here. So same start of everything. However, when we get to this bit where we say create the provider service, at this time it's not going to create a new service provider. It's going to get the same one that we created out of the cache. So we didn't really see all of that this time, but we saw all of that code last time. And this time it's getting that out of the cache so that we don't build that service provider again. And all it's doing is creating a new scope because we've got a new context instance. So we create a new scope, we initialize it, which we saw, and then we're going to get the model out of it. And again, so we're in the model, get the model factory here. Again, we see the model we already have, right? So we just return the model. So this is why the second time you call, the second time you use a DbContext, you don't get on model creating called again, right? On model creating happens in this piece of code in the model source, and it doesn't get called again because we're getting the model out of the cache. Okay, so we'll return that. And we're out of there. And then we're going through disposing things. So we're at dispose, step out of that, and we're done. Okay, so we can have questions if there are any, or I have, before we get onto pooling, because I think I want to show pooling because it's really interesting, but there's one thing I want to show before that, which we talked about a bit earlier. So rather than doing this, making these settable, we're just going to say, we're going to make them the expression bodies properties that call set of log. Right, and this is null friendly already, so you don't, because it's basically the compiler knows that these things are not nullable. This is my preferred pattern. Back in however long, 10 years ago or whatever, when we were doing DbContext for the first time in what became EF4.1, auto properties were basically this or nothing. If you didn't have a getter and a setter, you essentially had to go to a backing field and all of that stuff. You didn't have anything nice like this. And that was a lot of the motivation for doing this automatic setting of things. We wanted people to be able to create their DbContext with auto properties, not with backing fields and all of that stuff, not with writing code in their constructor, not any of that stuff. We wanted it to be really simple. Were we doing it now with this kind of syntax and the much more flexible auto properties that we have available, I think we probably wouldn't have done any of that stuff. But from back then, it made sense. And then once people got into the groove of, I can just create a DB set property on my context, and without even thinking about it, it's magically not null when I use it. Well, that's not something we wanted to take away. So that code is exists in EF Core as well. But nowadays, you can do something like this. Let's look at what the set method does. It gets this DbSet cache, which we were using before, and it calls this get or add set that we were jumping into before. So it's calling that same code that is actually being used when we generate the code to set it. But go back and let's run this test again. Debug that. We'll see that it doesn't do a lot of stuff in this case. Wait for it to get up. So remember, when we were doing find DB sets, we had this thing that said, yeah, find the DB sets, but then if you've got ones that don't have a setter, we don't care about them, right? And that's what we're going to see right now. So once we get into the code, come on. This is normally much faster when I'm not streaming at the same time, but I suppose that's understandable. I did shut down Teams, I think. Yes. Okay, so here we go into our DB context. So we're still finding the sets, but we didn't actually do any of that set initialization stuff because the sets are already, there's no setters on the sets, so there's nothing to set, there's no delegates to create, and so you end up with saving all of that stuff you've done that you would normally do. The downside is that when you call set the first time, it will go through that initialization process for actually creating the set. I suppose that's not really a downside. It means that it's actually more a lazier version of it in general than initializing. So that's why I would probably just use that mechanism. And then everything else is the same here, so we don't need to look at that. Notice also, I showed it, but I think it makes sense to really point it out. When you call this method, you're using the set cache. So you're still getting a single instance per context. So this will always return the same instance every time. It won't sometimes return one instance and then create another instance the next time you call it, and so on and so forth. So it's not the equivalent of doing new DbSet. It's equivalent of saying, if it isn't there, create it, put it in a dictionary. The next time, look up in the dictionary and get it. If you don't want to do that dictionary lookup, you could actually put a constructor on your DbContext, and you could initialize these eagerly beforehand, and then just return the value. So that's another valid option that avoids a dictionary lookup, but it's less lazy. It requires you to do that initialization. So it's kind of a cross between the two. Okay. So I'm going to go and move on to pooling, unless there's questions that we should cover before then.
So there's been various questions on thread safety, but maybe we can talk about that a little bit at the end, like a couple of minutes.
That's always fun to talk about.
Yes.
I have another test here. This test actually, we're going to create a constructor on here. Like so. Put the comment there, so that we can pass in DbContextOptions. I'm going to leave the onConfiguring there for a moment. But when we create, so there are two ways of using factories. Put DbContext factory. Let me say for a bit, this is DbContext pooling. This is not connection pooling. This is not in any way related to connection pooling, other than they're both pools. Completely different. So don't get confused by that.
Maybe it's worth
pooling for DbContext. Go, Shay.
Maybe it's worth making sure people understand the distinction. So connection pooling is, we typically connect you guys to databases, right? That's the whole point of EF Core. So there's a database driver, and there's a physical connection to a database, like an actual TCP socket there, typically, that's connected to a database. And when you're connecting to a database, you don't want to every time establish a new connection to the database, because creating that TCP connection and doing all that connection is very heavy. So in the database driver, which is not EF Core, that's under EF Core, in SQL Client, for example, there's what's called a connection pool, which reuses connection instances under the hood, again, to avoid creating TCP sockets and handshaking and all that kind of stuff. So that's connection pooling, which is not EF Core's concern. It's the concern of SQL Client or NPG SQL, the low-level database driver. But as we saw, now if we go up the stack back to where we are right now in EF Core, all the stuff that you saw now, it was about initializing a DB context. Now, a DB context is just an in-memory thing. There's nothing there that is, it doesn't represent yet a connection to a database. It holds a reference to a database connection, but in itself, it is only, an in-memory object. And what Arthur is now going to show is how to pool that thing, the DbContext thing, which is a pure EF Core in-memory object, which is your gateway to doing stuff. So don't confuse the two.
Indeed. So, so what I'm going to do actually is I'm going to show something that I think came up a little bit in the chat. I was just briefly looking while Shay was talking, and it kind of ties in nicely to the pooling. So in this case, what I've done here is I've created a DB context outside of onConfiguring. So this is what would happen if you did add DB context in a ASP.NET application with a service provider, an application service provider. And then In this case, I'm just newing up a DbContext and passing in, but if you resolved it from DI, it would be the same thing. So in this case, I'm going into this constructor on my context, which calls directly into this, rather than calling in the parameters one that then creates one, right? And I'm going to put a breakpoint here also on in my context on configuring. Okay, so what's going to happen here when we run this test? So we're not pooling again yet. When we run this, what happens is we configure our provider, right? So this is perhaps the same for every context instance we create. But we might actually want to configure different context instances differently. So for example, we may have different logging requirements in some cases than others. We may want to use an execution strategy in some cases. So not necessarily all our context instances have the same configuration. Alternately, we might want all of our context instances to do all the same configuration that they do normally, but use actually a different provider depending on what is passed into the context options initially. So the two things are not mutually exclusive. You can set options externally, and you can set options in on-configuring. Did I not debug it? I don't think I did. Debug selected test. And so that's why, even if you pass options in, we still call on-configuring. So in this case, we're setting the provider here. And then when we get into initializing the DB context, come on. Okay, here we go. So doing all of that stuff, and then when we go into, see, we're calling on configuring. So in here we have the options builder that already has the provider configured. So you can see it has the options extensions, of which one of them is the SQL Server options extension, which has the connection string that we configured, right? And we're then saying, on top of that, add this logging and do an enable sensitive data logging, because in this case I want to. So the two things are working together. So that's what I wanted to show there. Now, if we go back to our tests, and we start using pooling. So right here, go back up to the test. Okay, so pooling, you have to pass options into the pool. You have to configure the context externally. You can't use on configuring. And in fact, if we run this without debugging now, I'm pretty sure it should throw an exception. If it doesn't, then I don't know what I'm talking about. No. And the reason for this is the point of context pooling, as Shay was talking about, is to reuse the same context instance. So we don't want to be able to change its configuration in between different instances, otherwise things get really confusing. So what you feel on configuring cannot be used when to modify the DB context options when context pooling is enabled. Now, I know some of you are probably thinking, you could make that work. You could like check what's been there before and, you know, and all of that. And we could, but it's all adds complexity. And essentially one of the principles of pooling is it's much faster by not supporting some of the things, some of the power that you get from not using pooling. So this applies to, for example, injecting different DI services. If you're reusing the same instance, DI doesn't get a chance to create a new instance every time. It doesn't get a chance to inject different scope services into that instance, and so on and so forth. So you reduce some of the flexibility that you get by using the normal EF patterns, but at the same time you reduce some overhead, so that if you're in if the perf is important, or if you just don't need that flexibility, then you can get away without having it and be faster. So I'm going to remove this. I'm configuring from the context, and we'll now go and run this again. This time we'll run it in the debugger. Well, maybe I should show it works first. Let me just run it. Just go to recompile it. No support for EDMX, indeed. Okay, so we've got rid of that exception, do we? Yes, test passes. Okay, so let's start debugging it then. So again, I'm going to stop before we create the context instance. In this case, let me say, there's two ways to use context pooling. It integrates with DI. You can do add DB context pool, in which case the mechanics are slightly different, but conceptually it's the same thing. I guess I should have put a breakpoint on this. Yeah. So what we've done is we've actually gone into, so the mechanics are slightly different, or you can use a standalone pool. I'm using a standalone pool here. Conceptually, it's the same thing, just it interacts a little bit differently with when things get returned to the pool and so forth. In a DI thing, a context will get returned to the pool when the scope of that you've resolved the context from is disposed. Okay, so let's go look at this. So when we create a pool, let's see. So if we go back in the stack trace here, you see we're creating the DbContext factory, and to do that, we're creating a new DbContext pool. And in the DbContext pool, we do some validation. We freeze the options. Remember, we had that thing about not being able to use on configuring. This is what checks that you're not then trying to modify the options again in on configuring. They're frozen, basically. And then we create an activator. So what does that mean? Well, it means we need to be able to create instances of your DbContext, right? So you can do activator.create instance, and there's various ways of doing this. In our case, we want to make sure we call the correct constructor. So if we go back to where we're on the breakpoint now, what we're doing here is saying, give me the declared constructors on my DbContext type. And it's not static constructors and only public ones in this case. And I want there to be one of those. I want it to be non-ambiguous. We've got some issues on the backlog about making this a bit more flexible, which we could look into. But at the moment, you have to have one constructor which takes a DbContextOptions instance. And that makes it unambiguous what we're going to do to create your context instance. Again, remember I was saying how you use pooling, you lose some of this flexibility in order to get the perf of pooling. So we check that it's got one parameter. We check it's either a DbContextOptions or it's a DbContextOptions generic in the actual context type that we're using. And if it is, then we create a delegate to create that context instance. So again, we're just doing an expression to call new. We're passing in the options, and then we compile that. Okay, so this gives us an activator in the factory to use to create DbContext instances. Okay, so we do that once when we create the factory, and then we'll reuse that activator whenever we need a new instance. So we won't do any of that checking again, we'll just reuse that activator. Okay, so we've got a pool. Now we're going to go in here and actually use the pool to create a DbContext instance. Okay, so the way this works is we have this thing called a DbContext lease. This is essentially the thing that manages a DbContext in the pool. So if we jump into here, we'll say what the lease contains. I think it's a struct indeed, and it basically just says, okay, this is my pool. The standalone thing is, remember I was talking about you can use it with DI or you can use it standalone, so that kind of controls the behavior based on that, but it's not that important. And then we want to rent a context from the pool. So stepping into the rent method, here is where we look in the pool, and the pool is a concurrent queue, right? To the thread safety discussion, this has to be thread safe. Right, multiple threads can be asking for context from the pool at the same time. So this is the case where we're using a thread safe collection, in this case a concurrent queue. We go back to where we were. In this case, we should not have got so there was nothing in the queue. So this basically says if there is a context in the pool that we can use, then this is the code we run. Otherwise, remember we created that delegate activator to create the context instance. Run that. It's called our DbContext constructor. It's now going to go through all that stuff that we saw before in the normal case, right? It's creating the factories. It's going to set DB set properties if necessary. And ultimately, it's going to come out. There was nothing to set, and ultimately, it's going to come out, and we'll go back to where we were, which is here. We now have our DbContext instance. And then we're going to do snapshot configuration. So this is the configuration. Unlike the options that you specify in onConfiguring, there's certain things that are mutable as the context is being used. So the onConfiguring sets options that persist for the lifetime of a context instance, right? There's also things, for example, query tracking behavior, the lazy loading enabled, that kind of thing, that can be set dynamically as you're using the instance. So in that case, what we want to make sure is that when we put the context back in the pool, it gets, and it's taken out again, it gets that same configuration that it had beforehand. This code currently actually causes the context to be initialized when it snapshots the configuration. There's a PR out right now which actually changes that to not initialize the DB context if it doesn't need to be, if you haven't set any of these things. Not entirely sure if that's very useful, because probably if you get one out of the pool, you're going to use it. But it kind of, I did that in the PR because it kind of fulfills the contract of we create an instance, we don't initialize it unless you're really using it. Doesn't matter for now. Basically, we snapshot some of these things, which causes context services to be created. So we get the service provider. We're doing a bunch of stuff there. Step out of that. And again, and get out of that. But we're building the model even. Okay, so we're doing all of that stuff kind of eagerly, which is, perhaps not necessarily the best. But is not terribly important, as we'll see when we get to use it again. Let me just, okay. We'll get out of this eventually, I assure you. Okay, we're out of it. So it did actually more work than was necessary to snapshot the configuration. See previous comments about my PR. And then we will return the context. Okay. So we've now rented a context from the pool, and we set that context as the thing that the lease owns. In the create DB context, we've set the lease on that context, and we're now actually making sure that the context is correctly reset. We shouldn't actually have to do that the first time through, but again, it probably doesn't matter. And we've got a context, and we can get the model out of that. Actually, the model's already created and everything, so not much needs to happen there, and we get the model. Okay. Not much different there from when we did it without pooling, right? We still spent quite a lot of time going through initializing things, making sure everything was set up. That's what you kind of expect with pooling, right? The first time you do something and you haven't got anything in the pool, you have to go through some initialization stuff, but next time it's faster. Okay, before we get to the next time though, let's see what happens when you dispose that DB context. So in this case, we see that we've got a lease, and the lease is active and it's standalone. That means we need to, when we're disposing the context, dispose to when the service provider, that's what the standalone check is for. Instead of the scope being disposed, it's actually disposing the context, so we're going to return it to the pool. So we jump into this method that allows you to do that. Normally, dispose would do a bunch of stuff here. In this case, it's not doing all that stuff. It is instead going in and marking that lease as inactive. Okay, so that's essentially setting it to say I'm no longer being used. And we then jump into the lease here and say, okay, because we're again in the standalone mode, we're going to go into this release method, and that is going to return the context to the pool. So we finish using that context instance, it's back in the pool. So we come out of all of that, and we've now used it once, right? Now we're going to go into the context, into the pool, and say, give me a DB context again. This time, the context we've just used, we're not using anymore. It's been returned to the pool. We should just be able to get that one back right away, right? And this is where we really see the advantage of pooling. So if I step into here, we step into the lease, we step into the rent. Now we're going to go a different code path here. It's just like, oh, yeah, there was one there. Right, I've got it. I'm returning it. None of this stuff is happening. We're not calling the constructor again. We're not initializing DB sets again. We're not doing any of that stuff, right? Set the context. We set the lease. It's still going to do some stuff here to reset the DB context options, to reset the configuration, but it doesn't actually have to do very much. In fact, I just went one breakpoint there and we did everything, because again, the service provider's all been set. The DB context services that manage everything, those are all existing and everything. So basically, very, very little work when you pull the context out of the pool. And likewise, returning the model, everything is already initialized. We go into the model cache. It's already there. No model cache lookup. You just get the model super fast. So remember all of the things I was stepping over before? That's what you get. So you lose some of the flexibility when you go with pooling, but you get very, very fast reuse of the different context pools, which isn't to say that the other stuff is slow, right? I mean, we do all that work for caching and compiling delegates, so the normal path is fast. And if you're doing anything reasonable, any kind of reasonably complex query and save changes, you're not even going to be able to measure the difference between pooling and not pooling, right? But if all you're doing, which is a common thing to do, is get a context, do a simple query, return the results, and throw it away, then pooling will show a difference. So like in the Tech and Power benchmarks, pooling makes a difference, right? Yeah, I think that's yeah, and then putting it back to the pool as we said before. So I think that's basically what I wanted to show. Okay. I didn't do too bad. I didn't get too confused at the code. There's a lot of things there now that I'm like, I want to change that. But anyway. So, questions or?
Maybe we should say a few words on the thread safety thing,
Yes.
which everybody loves.
Yes.
So I think we had 3, maybe even 4 people asking, so what about DbContext being, using the same DbContext instance from multiple threads? Exactly. That's a good example. This is a question that we get a lot. So in many cases, people will get a DbContext instance, and sometimes they do it. They don't realize they do it, but they try to execute a query or do something from 2 different threads at the very same time. And we always say this in many places in our docs, in big red notes or whatever. DbContext is not a thread safe class, so you cannot use it from multiple threads at the same time. What you're supposed to do is basically have a DbContext for each thread that you're using, and not mix them around. And as Arthur mentioned at some point, we have even some controls in place internally. If you do happen to do this programming mistake of using the same context from multiple threads, there's a good chance we'll detect that and throw an exception, and we'll tell you, hey, you're trying to do this thing which is not supported. It's not 100% accurate. It will not always catch these errors, but it will help you out. So the question is why we don't allow you guys to just use the same DbContext, and it's more complex, I think, than you would think. So I mean, one reason for this is the following. So a DbContext basically corresponds to database connection under the hood, right? So when you're executing a query, DbContext will open a connection. There's going to be a database connection, and it's going to use that database connection for the operation. Now, database connections are never thread safe. They are a TCP socket to your database, right? So you cannot interleave at the same time from multiple threads, multiple queries on the same TCP connection. It will just get jumbled and, and error and bomb. So the first answer is that inherently, because DbContext encapsulates a database connection, that just doesn't make any sense. That's the first thing. But the second thing, which is a bit but then still, some people say, okay, so why don't you just create multiple connections under the hood for me, and then it will just help me do things in an easier way. So then what you guys usually have to realize when you're asking this question is that DbContext is designed to be a very stateful thing. It's a unit of work in general. So what you're doing is you're doing change tracking things. You're adding multiple things to your database. Now you're saying add this, change that, whatever, and then at the end you do save changes. That's kind of fundamentally incompatible with the idea of doing things concurrently on the same DbContext, right? Because if you have one thread that's now adding certain things and another thread is kind of coming in and doing save changes in the middle or attempting to add, it's all a mess, right? The whole idea of a DbContext is you have a set of operations you want to do. You want to query something, you want to change this property, you want to add something else, and then you want to save that whole thing back. That's 4 operations that you're doing, in a very serial way. It doesn't make sense to start jumbling that across threads in principle, right? So there's, in theory, yes, some people kind of say, yeah, but all I want to do is, one non-tracking query, right? I don't want EF core to track, so I just want to fire off my queries. I don't care, just make it work, right? So there may be some very, very constrained scenarios where, yes, EF core could, in theory, instantiate a connection for each query. And then because the query is non-tracking, it doesn't interact with chain tracking. So, right, there's no state of the DbContext that's actually there. Maybe we could make something work there. Even in that case, if we were to make that thread safe, that means we would add a lot of locking and safeguards in various places inside EF core that would make everything slower for everybody else who doesn't really need it, right? So what I'm trying to say is in most cases, it really doesn't make any sense at all, because you need that state, and the state conflicts with the idea of using concurrency. Even in the very restricted cases where you maybe don't need a lot of state, it would still slow things for everybody else. So what we're trying to say to you is, this sometimes happens. People come with this idea and they want EF core to work in a specific way, right? You come with your own preconceptions to a library. This is not an EF core thing. And you want the library to behave in the way that you want it to behave, but there's certain concepts. The library is designed in a certain way, and you have to understand how it's meant to be used. Otherwise, you're basically holding it wrong. It's like you're trying to use an oven in an incorrect way to cool something down, but that's not what an oven is made for, right? So that's kind of like my answer for this in general. There's no reason to not just have a lot of DbContext. Create as many of them as you want. We just showed that you can do that even very efficiently with DbContext pooling. You should not hesitate to create 100 DbContext. It's going to be fine. So just create one, run your query, and dispose it, and you're going to be completely fine with this. You shouldn't try to say, oh, but I want just one DbContext and then use it across my application. That's not the way EF core is designed to work, and for some very good reasons. I don't know if there's anything else to add or questions.
I'm always reminded when we have these discussions about the early days of Java. In Java, like 1.0 or whatever, they had a hash set or something similar to that, which was thread safe, and it basically got deprecated and replaced with non-thread safe ones, because all of the extra overhead with making it thread safe meant that it was really slow for the vast majority of cases that didn't need it to be thread safe. And I know it's a slightly different situation because that's a simple collection and there's wrappers to make them thread safe. But the general principle remains that if you make something thread safe by default, when most people using it don't want it to be thread safe, then you're adding a whole lot of overhead for all of the common cases that really you can't get rid of, and it's just not a good pattern to follow. Which is why throughout the .NET code, throughout the base class library, you'll basically see that things are not thread safe by default. The collections are not thread safe by default.
Exactly.
There's things like concurrent dictionary, concurrent queue that are built for when you need thread safety. The default dictionary implementation, the default dictionary of string to object or whatever you have, not thread safe, because you don't want all of that overhead in the majority of cases.
Yeah, it's like I understand people. I understand the idea that concurrency is difficult, so people would rather just have a thread safe thing that they can always just use, and it always just works. But programming, unfortunately, is a little bit more complicated than that. We can't always give a magic solution. We try whenever it's possible, but we can't always do it. So sometimes you just have to think about, yes, I'm using this, I have 2 threads and 2 of them need database connections. So each one of them knows up their DB context, and it's fine. And it's a very simple way to go about things.
So I just had a quick look through the chat, and I know Jeremy and Shay have done a really good job of answering, but just a couple of things I wanted to highlight. Can you have a private setter? We actually don't care whether your set is private or public when we're initializing DB Set Properties. This is a thing that Reflection doesn't care about, where if you're writing normal code, you can. So we will still set them even if you have private setters. Now, what was the next one? We talked about thread safety. Oh, somebody asked about, I kind of glossed over the resetting of the services, but yes, there's a mechanism whereby when you either put it back in the pool or get it from the pool, one or the other, we make sure that things like the change tracker are reset so that anything that was tracked before is not tracked. You can kind of do the same thing by calling context.changetracker.clear. That's been added, but that's automatically done for you when you're using the pool. I will say, though, there are limits to what we can do in terms of resetting state. And that particularly when you go down to the lower level objects like your DB connection. If you change some kind of options on DB connection dynamically while you're using it, we don't know that. We're not going to go through all of that. And this is, again, a pragmatic thing. If we try to reset everything, we'd end up being slower using the pool than not doing it. So basically, if you're going to change like the low-level configuration of your context, of your connection, for example, and then put the context back in the pool, it's not going to get reset by the DB context. So basically, the rule is, things that are EF state inside the context, we will reset. If you're messing with your lower level stuff, then just be careful what you're doing. Have a try finally in there or whatever to reset it yourself before you put it back in the pool. We need to document that, but that's a couple of people have run into that. Pooling has a potential of leaking if you don't give the context back to the pool. Yes, it does. So make sure you do.
But remember, so I think people are very, very scared because they're thinking, for example, about database connection pooling, which is awful. But remember, a DB context is just an in-memory object. So if you don't return it to the pool, the garbage collector will go and garbage collect it at some point, right? As long as there's no, so there's not necessarily a big problem here.
Well, will it though? Because isn't it still in the pool, or is it completely out of the pool? When
I think it's completely out. It's just out of that concurrent key, right? That you showed.
Yeah.
It's just an object out there that we're recycling. So
anyway, still don't do it.
Don't do it, exactly.
Yeah.
But it's not like a leak in the deadly. It's not a memory leak because it's not leaking in that sense, and it's not a connection pool leak. It's kind of benign.
If you've got disposable objects, dispose of them. Like you can get away with not disposing some disposable objects some of the time, but if you dispose disposable objects all of the time, then you're always going to be in the right thing. With the caveat, if you're using dependency injection, then it disposes some things for you automatically. You shouldn't automatically dispose them yourself.
And that's actually what I wanted to say. So if you're using, so what Arthur showed here was database connection pooling in standalone, which is where you are accessing the factory and then you're getting a context, and that means it's your responsibility to also dispose of it. But if you're using DI and you're in an ASP.NET Core application and you're using the method in DI to do pooling, then you don't need to worry about all that stuff because your database, your DB context is going to be returned to the pool immediately when the scope ends. So if you're in DI, it doesn't matter if you're using pooling or not using pooling. You're not going to leak. It's not going to change anything in that sense.
Yep, absolutely. And then one last thing I think before we go. Walking through EF code is like an expensive vacation. Lots of cash and time spent in the pools. Indeed, yes.
Good one.
Should have done this while I was in Santorini. I could have done it from the pool. No. And you can't have my cat. Good of
Cool.
Alice to show up here. Okay, so I think that's it, right? So we'll figure out what to do in 2 weeks' time. Probably the day before, like today. But anyway, hopefully we'll see you all back then. And as always, it's been a pleasure. So thanks for watching, and keep it sargeable.
Keep it sargeable.
Keep it sargeable, guys.